In this video, we're going to talk about plotting, and we're going to go over the most basic parts of plotting using Python, and specifically, we're going to talk about Matplotlib. This is going to be part 1 of 2. This is going to be over the most basic plotting concepts and how to do them. And then part 2 will be a little more complex. Okay, now before we start actually plotting data, there are some basics, some good practice to make plots that actually look good. So first off, if you're going to be publishing something, almost always square figures are the way to go. They scale well, they'll look good, they're always nice, they're always pleasant. Also, use large font size. As large a font size as you think you can get away with without it looking bad, cheesy. And share your font size across all components of the figure. So your labels, your axes, your comments, your legend, your tick marks, same font size for all of it. It'll just make your figure look very clean and, again, very easy to read no matter how it's scaled. Choose a good color palette. This can be hard. I suggest using something from Seaborn. We can look at that in the next video. And make sure that you use meaningful markers and line styles, especially when you have to distinguish between two samples. You can consistently color one sample and use the same marker for one sample, and a different color and a different marker for the other sample. And then there are some small things like make sure that the ticks face inwards. For some reason they default to outward facing tick marks. It's not as pretty. And a lot of the times if you add tick marks to the top and the right, they're called splines, I think, the little edges of the box, then your figure will look usually even better. So if you follow those basics for making plots look good, then you're going to have really good looking plots. Now, how do we actually do the plotting part? Okay, so the first thing we're going to need to do is we're going to need to import all the useful libraries. So I'll start by importing pandas as PD, so we can read in data. I'll import numpy as NP. In this case, it's so that we can generate data. I'm going to import matplotlib.pyplot as PLT, because of course that's the main focus of this video. And I'm going to grab matplotlib.gridspec as grid spec. Now grid spec is a way we can make more interesting plots with more than one panel in all kinds of places. Okay, so let's go ahead and just highlight this and hit F9 and we'll run that. Now what's the first thing we want to do? Well, let's make a very simple plot. So I'll say xdata equals np.random.normal. So I'm generating data from a normal distribution. We'll say size 300. Then the next step is let's say ydata is equal to np.exponent of xdata, and then let's get crazy and let's add some noise to this thing. So np.random.normal. So we're going to add noise from we're going to add our noise drawn from the normal distribution. And we'll say the mean is 0, the variance, or maybe that's the standard deviation, I don't remember, is 0.3, and the size is 300 to match our input. Okay. So, let's just zoom out just a tad there. Let's run this. Boom. And we'll generate these two data points. So in our variable explorer, we have x and we have y. Somewhat meaningless right now. But let's see what those things look like when we plot them. So we'll do plt for matplotlib.plot. And we're going to do x data, y data. And I'm going to explicitly tell it to use circles. And I'll show you some of the different options we have here. So now we have this nice little plot. And we see the new spider by default generates figures in a square, which is nice. And here's what we have. So it's decent looking. Now, without going into crazy detail, let's quickly make it look better. So these are going to be some of the commands you're always going to use. So as a starting point, I actually think I want to make all of the font sizes bigger. I'm going to go up here. I'm going to paste this in. Now, usually I just have this in one of my scripts and I find it and I use it across all of my plotting. And I adjust the font size as necessary. But in this case, when I run this, it's going to update the global font size across all figures. I'm going to run that. Now let's look at the same plot. Better. See how much more legible that is? Excellent. Okay. Now, let's define this figure's actual size. So this here is some default setting we don't control, but I can do plt.figure saying make a figure, and on that figure, give it a fig size equal to the x dimensions in inches, the y dimensions in inches. Usually 6 by 6 or 7 by 7 looks pretty good here. Let's see how that looks. Whoops. Excellent. So just a little bit smaller. And you'll notice because it's now 6 inches or 7 inches by 7 inches, the font size looks as if it's smaller. So you can adjust accordingly. Let's see how 6 by 6 looks. Maybe we'll leave 6 by 6 as our default figure size for now. So that's 6 inches by 6 inches. That's plenty big for most usages of a figure. Okay, so now the next thing we want to do is, it's showing it sort of like implicitly, but we can tell it to show this figure explicitly because Matplotlib doesn't know when you want to plot something. So currently it's going to run everything and then plot everything once it's done running. We can tell it to show things specifically. So it's going to run plt.figure. It's going to create a white canvas like this. Oh, did that not work? And then on that canvas, it's going to put our data, and then it's going to show that data on the canvas. Now, what do I mean by this? Let's say we had the same data. We offset it by, let's say 4. And we make it squares, and we make them red squares. So I can run it like this. And both of these things, so it made the canvas, it plotted the first one, it plotted the second one, appear on the same canvas, and then it shows it. Alternatively, if I wanted these individually, I could plot this one, and then I could make a new figure and plot this one. So now it's going to plot 2 separate figures, because this show command and then the creation of a new figure. Okay, well, let's keep those wrapped up together. And let's look at, quickly, some of the different plots you can do. So I'm going to make a new cell here, so I don't have to rerun that initial data every time. So without worrying too much about pretty looking plots, let me just show you some examples. So I'm going to generate some example X data. We're going to have A, B, and C. I'm going to get some Y data associated with that, maybe 111, 110, and 150. And let's look at a normal plot, plt.plot. We're just going to throw X and Y in there. Default values, plt.show. So this first one, it's lines at those points. Now A, B, and C are our quote-unquote X values, and these are the values associated with A, B, and C. We could do a scatter plot, which is similar to what I did up here, and we can do that in 2 ways. We could do explicitly telling it we want a 0. We could add the 0 and a line. So here's the, not the 0, sorry, the circles. Here's our markers and a line. We could make our markers squares and a line. Or, instead of doing that, we could say plt.scatter x, y. And this will give us circles. So if I run this cell now, first it's going to define x and y. It's going to plot the lines, and then it's going to plot the scatters. So here it plotted the lines, then it plotted the scatters. Okay. Well, what if we want a bar chart? Simple. plt bar x, y, plt.show. Just like that, a bar chart. And a horizontal bar chart is an h bar. And just like that, oh, sorry, I lied. It's bar h. But just like that, we get horizontal bar charts. And then there's a couple more interesting ones we can do. One that you'll find yourself using a lot is a histogram. Let me make this a new cell because we're no longer going to work with this x and y data. let's make, a distribution. And it's going to be mp.random.normal. So we're going to draw from a normal distribution. Maybe size is, let's say, 1,000. And yeah, we'll call that our variable distribution. Now if I want to plot this, see what this distribution looks like, I can do plt.hist distribution. And I can plot it and then show it just like this. And we get that nice little histogram. Now I can make it a little bit more detailed by saying bins equals, let's say, well, let's make it less detailed first. Let's do 4 bins. 1, 2, 3, 4. And let's go to the opposite end and do 40 bins. And we see that normal distribution starting to appear. And if we put this up to 5,000, even better. Now, let's look at plotting something with error bars, let's say. Now, so you don't have to see me type it out. I've got things copied over here. So let's say we have X data, we have Y data, and some errors associated with that. So I'm going to write this here. For the sake of being able to create this, our X data is going to come from a normal distribution. The error is going to come from a normal distribution for the X and Y. And our Y data is going to be our X data plus our X error. Well, this is sort of meaningless. If we were to run it and look at it, we can't tell much, but that's often the case with data you're working with. So let's go ahead and plot this. So we'll do plt.errorbar X data, Y data, and now we're going to give it Y error. So that's another input. Instead of just X and Y, we can give it X, Y, and the error associated with Y. And then finally, I'm going to say line style equals none. So don't show me a line. And cap size equals 3. So I want caps on my error bars. All right, let's see what that looks like. There we go, pretty. Now, you might wonder what happens if I don't include these extra arguments. If I just give it the required X, Y, and the error. Now I could also put X error here. Oh, X error, excuse me. And so now what we're going to get is lines connecting our error bars plus the error on the x-axis. And let's go back to line style equals none. And let's look at it one more time. There we go. So we have Y error, X error, and we have all these points on a line. I think this one looks the most pretty, so let's go with that for now. There's your plot of error bars. Now let's add those caps back, because I liked the caps. Cap size equals 3. Perfect. Okay. So that's it for extremely simple plots. Now, before I finish this video, let's go back to our first plot and add some extra details to make it even prettier. Okay, so first I'm going to make a cell out of this. And we're going to follow those things I said initially. So, item 1 was make your figure square. So we've made our figure square by saying fig size equals 6 inches by 6 inches. Good. Large font size, we set the font size up here. Good. Shared font size for labels, axes, comments, etc. So we only have tick marks, but let's add some labels. So this is pretty easy. We can come up into the data we're plotting, these X data, Y data, and we can say label equals original data. And that'll be a new label. Similarly over here, we can say label equals the +4 data. Now let's go ahead and run that and see what happens. You'll notice nothing changes, well, except for maybe this random noise. Let's go ahead and put that in its own cell so we work with the same data every time. But I can add a legend now, plt.legend. And here with our legend, ooh, no handles found. plt.legend. What happened is I showed my figure before I tried to create a legend. So if we create the legend and then show the figure, this is what we get. Our data plus a legend saying what our data labels are and the markers associated with them. Now, let's make things even prettier. Let's choose a better color palette. You know what? Let's go to Color Brewer for some color advice. So they have color palettes, and we're going to work with qualitative data. Let's say we're not worried about diverging values, and we're not looking at like a sequential set of numbers. So we're going to work with qualitative. Each of these colors represents a group. And we had 2 data. So let's go look. We can go to all the different colors associated with, only 3 classes. So these look pretty to me. But if we wanted, we could go colorblind safe, photocopy safe, none of those, or print friendly. All right, so make your choice. I'm going to choose these nice little like pastel colors. I'm just going to copy these. And these are hex figures, so let's just say colors equals. And I'm going to take this figure, and instead of having an O for circle or an R for red and an S for square, I'm going to explicitly say color equals colors 0. So I'm going to index this list with my hexadecimal coloring. So we come back, this hexadecimal number stands for this greenish color. This hex color is the orange one, and this hex is this purple one. So I'm going to go ahead and say color 0. And here I'm going to say color equals colors 1. Now we have 2 new colors, but we've lost our markers. So it's just lines again. So our answer there is to add let's get rid of the lines. So line style, we saw this before, equals none. And let's add a marker. Marker style, maybe, is a circle. Let's see if this works. Okay, so marker style isn't right. Marker. Okay, just marker with the circle. So now we have these little green circles. And let's do this same thing over here. So we're going to add a marker as a square with the line style none. Let's zoom out a little bit, make this a little cleaner. We have our 2 different plots. Now the next thing we want to do, in my opinion, is I like to have the marker edge color equal black. And I'll do that for both of these. Now I'll run that. Getting better. And then sometimes the marker size looks better if it's been adjusted. Let's throw both marker sizes at 7. Pretty good. And maybe for personal taste, I like to add an alpha, which is transparency. So at 0.8, we are somewhat transparent, but not extremely transparent. So let's go ahead and throw that in there. Getting better. So some of the other things we can do to make this figure really good is, after the good color palette, meaningful markers and line styles. I think we've done a good job there. I'm now going to fix the tick markers. So plt.tick params. This is going to be changing the parameters that build these tick markers. I'll say top equals true. So I'm going to add ticks to the top. Same with the right. And then finally I'm going to say direction equals in. So I want the ticks to point towards my data. Even better. And then as a last step, I think stylistically for this figure, we can add more length to these ticks. Maybe length 9. Perfect. So now we've created what I think is a somewhat better figure than that initial default one. But ultimately it's up to you to figure out what you think looks good and to make that happen. So the next video is going to be going over some more advanced plotting functions or plotting capabilities you can do with Matplotlib. But within that, remember that we always want the figures to not just be complicated, but to look good and convey the information well. And in fact, on this figure we have, let's add one last thing. X label. Let's say these are our X values. And we can even get crazy. We'll say our Y label is some Greek letter. So we can do my Greek letter. Whoops. And let's say it's theta. So I'll do first dollar signs. And inside those dollar signs, I'll do a double slash with the Greek letter I want. Let's do a theta. And let's run that. And ooh, we get a capital theta. Now if we do a lowercase t on that theta, we get the lowercase theta. And we can do pi. We can go through all the crazy Greek letters. And we could even put words in here, but these little dollar signs denote a LaTeX math environment. So if I put these words in here, you're going to notice they're going to look as if they were words in an equation. So perhaps more appropriately would be like x plus or y equals mx plus b. Now that's going to look very good, like an actual equation. Okay, anyways, watch the next video as well, but hopefully this gets you started in thinking about how Matplotlib would work for helping you make and create figures. Good luck.